Okay, so now for finding the mesh currents, we'll use our mesh current equations here. So we know that IA is 2 amperes, and to solve for IB, you just solve this equation. So sub this with 2, the 2 amperes is from here, and then if you solve this, you should get IB is equals to 1 ampere. Okay, so our answers are 1, and IB is sorry, IA is 2, IB is 1. Uh, okay. Wait. These are wrong answers, okay? So ignore them. Ignore, please. Ignore, please. Ignore. Okay. Let me just redo it anyways. Okay. So based on the numerical values that we got from figure 1, determine the power generated or dissipated by each resistor. So when you encounter this kind of question, I strongly suggest you write this out for them. Okay? Write this out, sorry. So you must put a legend for the examiner. You must tell the examiner, okay, positive power means power dissipated, and negative power means power generated. Okay, it's just for clarity's sake. And then for the power, we shall use the formula P is equal to I delta V, where delta V is V start minus Vn. Okay, you must strictly follow this formula. So let us find all the powers of the resistor. Resistor 1, 2, 3, 4. And then after that, we have the voltage sources and the current source. Okay, so I delta V. So what is the I going through R1? Let us check. So what I suggest is after you have solved the values for the node voltages and the mesh currents, please label them on the diagram. So you see, for example, VA is 20, VB is 0, VC is -10, VD is 0, and so on. Okay, it helps you easily identify the V starts and V ends. So let us look at R1. Okay, and the mesh current is this, which is 2 amperes, and this, which is 1 ampere. Okay, so who is the current going through R1? It's just this 2 amperes, right? See, the 2 amperes is passing through R1. So current through R1 is 2 amperes. And what is the V start minus Vn of R1? So since the current is flowing in this direction, see, V start minus Vn. So 20 minus 0. So 20 minus 0. Now let's look at R2. So R2 is a bit complicated. Why? Because there are the currents clashing at each other. So let us take a closer look. So we have I2, which is flowing like this, right? Notice that it is going to the right in this branch that R2 is sitting in, right? It's going towards the right side. Whereas this 1 ampere current is moving to the left. So what is the direction of the net current through R2? The direction of the net current is given by the direction of the larger current. See, 2 and 1, who is larger? Definitely it will be 2. So 2 is larger, hence the net current will flow in this direction, in the direction of 2 amperes. But what is the magnitude of the net current? You just take 2 minus 1, because 1 is opposing the 2. So the net current is 1 ampere. Now, what is the V start minus Vn of R2? V start minus Vn. So it starts at 0, it ends at -10. So the power is given by this 0 minus -10. Okay, so oops, sorry. So this is 40 and this is +10. Then R3 is what? R3 is, okay, current going through R3 is, see, it's just this 1 ampere. And what is the V start minus Vn of R3? See, it starts at here, which is 0 volts, and then it ends at here, which is -10. So 0 minus -10 multiplied by the 1 ampere current. So 1, 0 minus -10. Now look at R4. So the current is still this 1 ampere flowing through R4. But what is the V start minus V end? It starts at here, it ends at -10. So 0 minus -10. That's the delta V. So this is 1 ampere, 0 minus -10, which is just 10. Okay. Now let us take a look at the voltage sources. Voltage sources, let's look at V1. V1, what's the current flowing through V1? It's still this 1 ampere flowing through V1. And then you see the direction of the current. It starts from here, it ends at here. So -10 minus 0. V start minus V end. Then PV2, look at the V2. What is the current? The current is just this 2 ampere mesh current. Okay. And what's the direction? It flows from here and goes through here, right? Flowing along this anti-clockwise direction. So let me just clear this up. It starts from -10, it ends at 0. -10 minus 0, that is the delta V. So the current is 2 times, so 2 times -10 minus 0, this is -20. Then lastly, we have the current source. The current source, of course, the current source, the current direction follows the arrow, so this way. So it starts at 0, it ends at 20. V start minus V end is 0 minus 20. Okay, so how do we prove power conservation? So to prove power conservation, what we need to do is you sum up all the powers of the devices, including their signs, negative and positive, and then they must give you 0. So take this plus this plus this plus this plus this plus this plus this. Okay, so the sum of the powers is given by 4D plus 10 plus 10 plus 10 plus -10 plus -20 plus -40. Then you should get 0. So power is conserved. Since sum of all powers is given to be 0, the power is conserved. Why? Because this 0 shows that there is a balance between the power being generated and the power being dissipated. So since they cancel out each other, there's no the circuit as a whole has no net creation or destruction of energy. So power is conserved.